in this segment, I want us to talk about ordinal addition. And in particular, to go through the official definition of ordinal addition to make sure you're all clear about what's going on. So our official definition has 3 clauses. One clause for the case in which what you're adding to alpha is 0. Another case where what you're adding to alpha is a successor ordinal. And then another case in which what you're adding to alpha is a limit ordinal. And the best way to understand what's going on is to see it in action. So what I thought we'd do is first show that omega plus 1, omega plus 0 prime, is just omega prime, and then show that 1 plus omega, or 0 prime plus omega, is just omega. So this will be a nice way of illustrating the fact that addition does not commute, because since omega prime is different to omega, this means that omega plus 1 is not the same as 1 plus omega. So let's start with this one here. So omega plus 0 prime is a special case of our second identity, because omega prime is a successor ordinal, so it takes the place of beta. So by our second identity, that is the same as omega plus 0 prime. But omega plus 0, by our first identity, is just omega. So we reached our result. Omega plus 1 is just omega prime. Let's now verify this identity. So omega is a limit ordinal, so we need to look at our third identity, which tells us that 1 plus omega is the union of the set of ordinals 1 plus beta for beta smaller than omega. But omega is just the set of finite ordinals. So that's the same as this set. The union of the set of ordinals 1 plus n for n, a finite ordinal. In other words, the union of the set whose elements are 1 plus 0, 1 plus 1, 1 plus 2, and so forth. So let's now see who each of these is. So 1 plus 0, by our first identity, is just 1. 1 plus 1, we can do it here, by our second identity, is 1 plus 0 prime. But we know by the first identity that 1 plus 0 is just 1. So we get 0 double prime, and so forth. So this set is just the set of finite ordinals starting with 1. And their union is simply the result of pooling together the elements of her and the elements of him and of her and of him and so forth. So it's the set that we get when we take the element of 1, so let me write these down just so we know what they are. So 1 is just the set containing 0, 2 is the set containing 0 and 1, 3 is the set containing 0, 1, and 2. So we pulled together every element in 1, so 0, plus every element in 2, which is 0, it's already there, and 1, plus every element in 3, 0 and 1 are already there, plus 2, and so forth. And this, of course, is just omega. So we've proved our result. 1 plus omega is just omega.